Within the world of Brunstad-Lowry acidity, we want to see how we can generalize certain ideas or certain concepts and patterns that show up in these reactions. The first thing we want to talk about is called conjugate pairs. So in a Brunstad-Lowry acid-base reaction, you know you have this H plus that's moving around. So those are really small changes and predictable changes in molecules. And so what we can look at is we can define a conjugate pair as two molecules that are related by either the loss or gain of electrons. So suppose I start with HF. If HF loses one H plus, so that would mean it is behaving as an acid, it loses an H plus, so it would lose that H, and it would lose positive charge. And so what would be left would be F minus. So what that means is we call F minus the conjugate base of HF. So what that means is if HF behaves as an acid and loses H plus, you would generate F minus or fluoride. So fluoride would be what would come out of it. Conversely, with that pair, it also would be true that if fluoride behaves as a base, where it would gain an H plus, it would produce HF. And that means that HF is the conjugate acid of F minus. So we can make these sorts of predictions. So F minus, if it were to behave as a base, it would turn into or form HF. So that's what makes them a conjugate pair. And again, it's only about the loss and gain of a single H plus. So one H plus at a time, because that's how these reactions progress, changing one at a time. One of the H pluses, one H plus gets moved from one atom to another. Small changes. So let's look at an example. Let's see if we can identify the conjugate acid for each of the following molecules. I have NH3, HSO3 minus, and H2O. Okay, conjugate acid. So I want conjugate acid for each of the following molecules. So conjugate acid, when we see that word acid, what that means is that the molecule we're creating will have an extra hydrogen. So basically we want to think about what happens when these molecules act as a base. So if each of these molecules acts as a base, what will it create? So we know when we're talking about acid-base chemistry, all that's going to change are the hydrogens. So everything else is going to be the same. So in this case, that starts with an N. So the conjugate acid is still going to have an N. And so I'm still going to have H. I have the H3, so I know I'm acting as a base. I have the H's. What this means is that I gain H plus. So I did have NH3. Bases gain an NH plus, so the number of hydrogens goes up to 4 because I was at 3 plus 1 gets me to 4, and I was neutral. It goes to positive. So this was a charge of 0. So you can see what I do is I increase the number of hydrogens by 1, and I increase the charge by 1. So HSO3 minus. The SO3 is going to be exactly the same. That never changes. Acid-base chemistry, you're only affecting the hydrogens. So I did have one hydrogen here. That becomes H2. I increased the number of hydrogens by 1, and I increased the charge by 1. It was negative, so -1 plus +1 gives me 0. So the charge is 0. This is a neutral compound. It just becomes H2SO3. So conjugate acid always has one extra hydrogen and one more positive charge. H2O, O is going to stay exactly the same. H2 becomes H3O plus. Right? The hydrogens have to go up by 1, and the charge has to go up by 1. We always are going to increase the number of hydrogens by 1 and the charge by 1 because it's an H plus that the base gains.
So when we're looking at conjugate acid, we want to think, when these molecules are acting as base. So getting the conjugate base would be the opposite, right? One of the things you'll note, this conjugate acid, you'll see always has, because the acid, we're talking about what you make, always has one extra hydrogen. So always has one extra hydrogen than what you started with. So conjugate base would be the opposite, one fewer hydrogen and one lower charge.
Participation 10.7, question 1. Identify the conjugate base for each of the following molecules. A, H2SO4, B, HSO3-, and C, H2O. This is the first question on participation 10.7 due Tuesday, October 7th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, identify the conjugate base for each of the following molecules. It's sulfuric acid, hydrogen sulfite, and water. Okay, got our first participation question for 10.7. More videos to go. See you there.